Hi everyone, uh, my name is Kingsley Idoko, and I want to welcome you to this section of my video. In this section, we're going to be talking about how to implement the full mesh iBGP pairing. Previously, we talked about the different uh, iBGP scaling method. We said we had full mesh designs, we have the raw reflector designs, and we have the confederation design. We already talked about the different advantages and disadvantages of the different designs. So here we are going to actually do the implementation so that we can actually come to see these different variations with the designs and which one is much more flexible or much more easier to implement. So we did say that okay for the full mesh designs that it has its advantages, right? Things like optimal traffic forwarding, there's path diversity, there's faster convergence time, and you have this sort of robustness within the network because even when a link fails or a node fails because you have this multi-paths to different destination, you can quickly uh, fail over or reroute around those failures because of the path diversity that actually exists. Then we also said that, however, that for the full mesh designs, it's actually very difficult to implement in that it is configuration intensive, being that with just 10 routers, we did say that you need to have like 45 pairings from both from your end and also from whoever you're pairing with. And we did say there's a lot of management overhead, and you have a lot of duplications of information. So let's actually do the implementation and let's come to see this point that we're trying to bring out so that it becomes much more easier for us to understand. Now this is my topology that we're going to be working with. Uh, so in this topology, what we are going to have is this. So this specifically is going to be my, let me bring out my pen. Okay, so this is going to represent the call like I earlier explained. So if I bring out the pen now, so this is going to represent the call of our network. So from router 1 down to router 3, all the way to router 4, then all the way to router 2. So this represents the call of our network. So what we're going to be doing is that we're going to be enabling some sort of IGP within your the call of your network. In this case, I'm going to be using ISIS. Uh, you can basically use anything you want, like you could use OSPF, right? And you can also use AIGRP. Uh, but of course, you know AIGRP is not really used within a service provider environment. So if this network is actually built off of a service provider, it means you probably not be running AIGRP, of course, because AIGRP is not extensible. I mean, you can't write extensions to AIGRP, so that's one of the reasons why it's not uh, used within a service provider environment or within a BGP MPLS network. So you could either run ISIS, flat level 2 ISIS, or you can simply run OSPF. In this case, just on area 0. So just like I've said, in this our implementation, I'm going to be using ISIS. ISIS, I would say, is rather much uh, more difficult to configure as compared to OSPF and AIGRP because you don't really have a command that you just enable on this router that automatically enable ISIS. You have to go into the process, you have to specify the network identity title, which is more of the area and the system ID. Then you have to specify the address family, and then you have to enable metric style Y. So I'm just going to show you what I did. I've actually gone ahead to enable ISIS within the core. Uh, and so that you probably see how we can also configure it should you choose to follow with the lab, which I strongly encourage that we all should do. Okay, so within the just hold on. So within the core, we are going to be forming iBGP pairing, right? So we talk about the full mesh design. So with the full mesh design, it means every router is going to be paired with every other router, right? So we are going to have these full mesh designs between all the routers within the core. Okay, similarly, router 3 is going to be pairing with router 7, with router 2, with router 3. So that's only router 3 with router 9 and with router 4. Same with 4. So in the end, you see, you sort of have this sort of a lot of pairing that's going to be happening within the core, because what we're trying to achieve is the full mesh implementation. So when you look at the number of routers we have here, which is about 7 of them, if I bring out my pen, so that means how many parents do we need to have here? So that's going to be 7 multiplied by 7 minus 1 divided by 2. So this is going to give you about 42 divided by 2. So 42 by 42 is going to give you about 21 pairing altogether. That's a lot, right? So that is one of the big challenge with using the full mesh design, because the number of pairings, because it's always every node is going to be paired with every other node within your core. You now have this a lot of BGP configurations that are going to be involved when you are enabling BGP full mesh design. So, however, for the other routers that are not within the core, so this is so between router 1 and router 5, we are going to be forming an iBGP pairing. So, uh, same way with router 5 and router 3 is going to be an iBGP pairing. So we're going to be running autonomous 56 between for router 5 and router 6. So router 5 and router 6 actually within the same autonomous system. So, but however, they are going to be having what we call a dual last mile connectivity to the core of the network. So in between these two devices, between these two routers, is going to be iBGP. Okay. Same way for router 11, here is going to be also an iBGP pairing. Okay, but the difference is we're going to be running a private autonomous system here. So we're going to choose an autonomous system of 65011. Same way for router 10. So router 10, we're just going to use its autonomous system. We're going to use an autonomous system of 10, which is a public autonomous system. So we're going to assume that this is a private peering, while this is more for the transit connectivity. So, however, for this you could liken this to something like an L2 on an L3 VPN service, where what the customer just want is connectivity between. Like, so if here is your HQ, here is going to be at the branch. So they want connectivity over your core, which is going to be running BGP and MPLS. We'll talk about MPLS later. We're going to see how BGP actually support multi-protocol for VPN v4 and as well as VPN v6. So having this information in the back of our mind, let's see how we can do this implementation. So first, like I said, we are going to begin by enabling IGP within the core. The reason why you need to enable IGP is to provide transport for the routers. I remember, unlike AIGRP and OSPF that have their own protocol, which is protocol 88 and 89, uh, BGP typically relies on TCP, right? So TCP port 179, and you also need IGP for transport and also for recursion. So TCP and IGP needs this for to provide transport. So for router 1 to be able to form peering with router 4, there has to be some sort of transport within the connectivity so that they can form peering. And so this is achievable by simply enabling an IGP, because when we say okay, to get to this router 4, our next stop is router 7. Router 1 needs to be able to recurse to this router 7 in order to get to router 4. So that's what we are going to be doing. So I've already enabled ISIS. I'm going to show you what I did both for the iOS and the iOS XR. You can pause the video and do it yourself. However, by the end of the video, or by the time you'll be watching this video, I would have uploaded the initial config for all the routers, so you can simply download them from my Mediafire account, and you can simply use them to kind of get started or bring you up to the current steps that we are working on now. So I take this out and bring out my pen. So this is my Genesis topology that we've all been working with ever since, and I already have my console access to all of them. You see router 11 is complaining of memory. Of course, when you are running iOS XE, it takes a lot of memory, and so if you don't have enough memory, then those routers is just going to complain. But nonetheless, it doesn't stop us from doing what we have to do. So we should be fine with this. All right. So I earlier said that if you don't have enough memory to run all these Qmon images for iOS and for iOS XR, you can as well use the 7200 router that is available in GNS 3, or you can simply use the IOU images for routers. Alright, so with that, you should be able to still test most of the commands. Of course, for XRO, I don't think you have those kind of version. It always has to be the QMO image, and so uh, you can actually know how to actually lab this topology up. So if I go to router 1, okay, so you can see that I've actually saved my initial config on the router. So what I simply did was to load this config into my running config, so we can actually move forward. So at the end of every single implementation that we're going to do, I'm going to save the config, so that should in case we want to revert back, this is going to be a very easy way to do that. Okay. um, so if I say show run router iSize, so you see that I've already enabled the iSize process. So in this case, this is for iOS XRO. I said I want to run flat level 2. So you have level 1, level 2. If you don't specify what the type of eye size level that you want, or eye size type you want to run, is going to default to level 1 and level 2. But in this case, I'm running flat level 2, which is what you mostly find within the service provider environment, that they are going to be running some sort of flat eye size, because most service provider environment is really flat and a scalable network. So this is my network identity title. You have my area, you have my system ID, you have the I think they call this the X selector, which is usually 00. Here I'm logging my adjacency changes. So whenever there's it's just similar to your BGP log adjacency changes that we actually showed you earlier. So this is what enables us to see the different ISIS messages that go back and forth between the routers. So this, you always have to specify the address family. I always say that for iOS XRO, the default is there's no default address family, so we do need to specifically specify which one we are going to be running. So the matrix start white also allows ISIs to work efficiently. I think the default is narrow, but we are enabling the wide metric. This adds to its extensibility. So uh, we're not really going to start explaining what this does, of course, but we are just enabling it for ISIs. So currently, loopback 0 is enabled for ISIs. The ISIs process is running on that interface. Similarly, gigabit 0.172 is also enabled for ISIs. So the case depends on the number of routers that you want to enable. You're going to see that for XRO configuration is way different from your iOS, right? Because the interfaces and the loopback interfaces are all within or underneath the global process for ISIS. However, if you go to your normal iOS XRO, I mean your normal iOS X's, if I say show run, you're going to see that if you go down here, um, you see first the ISIS is enabled on the interface level, okay, for iOS, your normal iOS. However, on the we still need to enable the process. We need to specify the network identity title. They also say that we are running the metric style Y as well as level 2 flat network. So the configuration is really not that difficult. Uh, there are a lot of videos on the internet and on you know where you can learn the basic way you can enable ISIS on both an iOS device and also an iOS XRO device. Um, so that's it. Uh, so if you also go to other routers, you see the configuration is definitely going to be the same. Let's go, if we look at the routing table now, I say show IP route for ISIS. You're going to see that we are learning a whole lot of prefixes. If you look at it from learning prefixes from router 1, we are learning prefixes from router 2, we are learning from router 4, router 7, router 8, and router 9. You know that for your customers, you're not going to be running an IGP with them. So our IGP boundary is going to be around those provider edge devices that actually connect directly to the customers. So we also have all these other net prefixes here, which are the more like your point-to-point or the networks that exist between the nodes. These are the loopback interfaces, which are also enabled for ISIS. So that's why we are able to see them here. Same for router 1. So if I go to router 1 and say show route, I can see for ISIS. Okay, so just me, this is the prefixes. It's actually learning from those neighbors. Okay, so the first thing we need to establish now is who can we get to every node within the infrastructure. We need to be sure that there's transport from router 1 to every other router within the domain. Now the domain, like I earlier explained, covers your router 1. So between your router 1 and router 3 and router 4 and router 2. So all these routers are within the service provider environment. So we need to ensure that from router 1, we're able to ping every interfaces or every loopback address of every node within the ecosystem or within the service provider network. So to do that, there are different ways we can do that. You can actually use you can do the ping manually. So I can just come here and say I want to ping 172.20 dot let's say 2.2. So I'm going to say source is going to be 172.20.1.1. You can see that I have reachability. Same way I can say for 3.3. Sorry, should have been. So I can as well come here and say, okay, for 3.3, What do I have reachability? You're going to see you have reachability. Now, normally you use some kind of script or like your Tico script to actually pull that off. So if I want to do that, all I need to do is to, let's say if I bring up my, let me bring up a new page for Notepad. So if I bring up my Notepad, uh, so I'm going to say, I want to set the interface. So I'm going to say, so firstly, the way you do it in iOS and iOS XR is slightly different. For iOS XR, I'm going to say I want to run Tico scripts. Okay, the Tico shell. So here I'm going to set the interface. I could say my interface or my source interface is going to be 172.20.1.1. Okay, so I'm going to hit enter. Then I'm going to say for that for each of the variable. Okay, so my variables now are going to be uh, uh, they are going to be 172 dot we could actually include our own loopback. So here I'm going to say 172.20.1.1, 172.20.2.2, 172.20.3.3, 172.20.4.4, 172.20. Then we go to 7.7, 172.20.8.8, 172.20.9.9. All right, so when we are done with that, you can of course close the bracket, the brace bracket. I'm going to say I want to ping. Uh, so what do we want to ping now? I'm going to ping with the source. I'm going to say source is going to be uh, so the source is going to be my I, which is the source interface. So I'm going to use the dollar sign to point to that variable I. Then the source is going to be that interface. Then the destination is going to be the variable. So I'm going to use the dollar sign again and say for use the var keyword, which is our variable. So I'm going to close it. Okay, so if I had wanted it to, maybe I could have said I want the repeat count to be at 10. If I wanted to add that, and then all I just need to do is to copy this and paste it on router 1. So once I paste, so we have our script. So once I hit enter, it's going to run through and we are going to be so here will automatically tell us where we don't have reachability. So as it currently stands now, I have reachability to router 1, which is router 1 itself. I have reachability to router 2, I have reachability to router 3, same with router 4, with router 7, router 8, and with router 9. So if you look at the topology, that is exactly the routers that we have reachability to. So one has reachability to router 7. However, for router 5 and router 6, as well as router 10 and 11, because they are not in the same BGP domain, and we don't expect us to have reachability for now because we are not running IGP with them. So if I use my Control C, it's just going to take me out of my Tico shell. Same way for your iOS XR, your iOS XE. You'll probably be more familiar with this. All I need to do here is to say I want to run Tico shell. Okay, then I'm going to say for each, same way. So I'm just going to say for each variable in just open my brace brackets and loading my value. So I'm just going to copy this again and paste. I'm going to copy and paste it here. Let me go through. So I'm going to copy this. If I expand my notepad, so I'm going to put it here and paste. Let me take it a little bit up. Then I'm going to close my brackets. I'm not really an expert in Tico's script, but uh, you can definitely use it for this basic connectivity test. So I'm just going to say I want to ping the variable. Okay, so my variable now is var. Then I'm going to say the source is going to be my loopback 0 address. Okay, so I'm going to close this. I'm going to copy. Then if I go back to any of the iOS XA routers, I'm going to paste it. I'm going to hit enter. So this is another way we can as well test it for iOS XE or your normal iOS. So when you are done, you just simply say equal quit, or you can simply type the exit. That takes you out of your article the shell. So this is just the variation. So for iOS XR, this is what you use. For iOS XA, this is what you probably use. If you see in this case, we actually included the number of counts, which we said should be 10. All right, so I assume we have full basic or full reachability between all the routers within the core of our network. So with that, we can start to enable BGP peering among all the routers. So if I bring out my topology again, so let's begin with router 1. So router 1 is an iOS XR. Now one thing you are going to notice for BGP is that BGP uh, has is configuration intensive, right? So BGP, unlike multicast, requires a lot of configurations that you are going to have to type in to enable the BGP sessions. So router 1, let's begin. All I just need to do is to come here and say I want to run router BGP. So I'm going to use BGP process of 1. Okay, so I'm going to enable it for address family IP version 4 unicast. So I'm going to add the keyword unicast. Then I'm going to come out of the AF address family uh, information. So we can start doing the peering now. Now the thing is, there are different ways we can actually manage these configurations. All right, so I can be doing them I can decide to do them individually by saying neighbor, neighbor 172 to 20.2.2. Then I can come here and say neighbor I want to say remote AS is 1. I'm going to enable it for address family IPv4. I'm going to say, okay, my update source is going to be loopback 0. Then I'm going to say my address family is going to be IPv4 for that process. And pretty much will be fine, right? But of course, there's going to be a lot of repetitions, okay? Which is one of the big challenge with full mesh designs. But one of the easiest ways, so if I simply say show configuration here, you see this basically enables BGP peering with router 2. So all we just need to do is also repeat the same thing from that router 2 box, and I bet you the BGP session is going to come up. All right, so I'm here to commit this config because I don't really want to go through this process. I don't want to go through this route. Rather, I want a more simpler way of actually implementing this. Now later we're going to talk about the different ways you can actually scale iBGP or manage the iBGP configurations. Um, there are different ways. We're going to talk about the things like the what we call templates. So we could use templates. Templates are much way of separating the global BGP configurations and the what we call the address family specific information. So we're going to talk about things like templates, things like peer sessions. Okay, we're going to see how we can use peer sessions to manage BGP configuration. We're going to also talk about things like peer policy, which is address family specific configurations. We're also going to talk about peer groups. Okay, so in this case, we're going to be using peer groups here. What I like about peer groups is Peer group is a combination of your peer sessions and your peer policy. So within the peer group, I can specify both global BGP configurations as well as address specific address family configuration. We also talk about inheritance within BGP. So if I already have a peer session and I have peers policies, all I need to do is to inherit them as I peer with inherit the parameters from these different templates as I pair with my neighbor. So for this Fox example that we're going to be doing, I'm going to be using peer group. Later, maybe when we're doing route reflectors, I'm going to show you how you can as well use peer group and peer policies, AF groups, and there's a whole lot more that we're going to talk about when it comes to managing BGP configurations. Okay, so moving forward, like I said, we're going to be using peer group. So let's see how we can achieve that. So I'm just going to abort this configuration. So abort is a way of saying whatever configuration I typed in, I don't want to save it, I don't want to apply it. I just want to get out of that those configurations. So I'm going to go back now. So I'm going to say route BGP1. Okay, so the next thing we're going to do is we already enabled the address family, right? So I'm going to say uh, BGP, is it peer group or I'm going to say peer. Now you can always use your what's it called? You can always use your uh, your help to find out what your command is. I personally I don't memorize commands. If I'm having issues, I already know this is how it should be. But if it happens I don't remember the syntax, all I just need is to use the sensitive help that is available on the parser to find my way around what I'm supposed to implement. So what we're actually looking for is the neighbor group. Now in XRO it's called the neighbor group. I think in XC is called a peer group, so that is was what was kind of creating the confusion. So here I'm going to say for the neighbor group, okay, neighbor dash group. If I use my question mark, I'm going to give it a name. I'm just going to call it the KI group. KI group. All right. So I'm going to hit. So now we can specify what our parameters should be. Okay. So things like for the neighbor group KI, I want the remote AS to be 1. Okay, so this is just a way we can specify those parameters. I can say I want the update source to be loopback 0. Okay, so I can also say I want the what other thing do we need to specify? I want the address family to be IPv4 unicast. Okay, so something else we might need to do, I don't think that is part of it. I can also say for that neighbor, uh, so we have remote pair, we have update source, right? So if we needed to do things like route reflection, we could have just say route reflectors. I think it should take it to. So for this question mark, you also have other options that we could have included. So if we want to set maybe something like the password for all our sessions, maybe something like the TTL security. Okay, so we also want to set the timers. We've not talked about the timers. I hope we'll be able to talk about it in this maybe in this session or subsequent sessions. If we want to do graceful restart, we want to do eBGP multi-hop, we can as well specify some of those things here. So basically what we need is the remote AS and the update source, right? So in this case, we are all going to always be pairing with what's it called? We're going to be pairing to their loopback addresses. Later, you're going to see why it's very important. It makes it much more easy for our pairing rather than using the physical interface. So if I say show configuration, okay, so this is what we currently have. So I have a neighbor group that I just created and has included my parameters. All right, so I've included the address family, I've included the update source, and also included uh, the uh, the remote AS is. So what I just need to do now is to commit this command. So once I commit, we're good. So I'm going to get out of that So if I go back in router BGP1, so I'm now going to say for the address family IPv4, which we have already enabled. So I'm going to say for neighbor. So now we can start adding the neighbors. 172.20.2.2. So I'm going to say this time I want to use the peer what. So if I use the question mark, it's going to say the neighbor group, which is the KI dash group. Okay, so make sure it exists. Now, what I like the XRO for is that it already know whatever you save is always cached in memory, so it's easy for you to recall it and then use it. So this is what we're going to do for all our neighbors. So what I'm going to do here is I'm just going to grab this. So you are going to see that when you are configuring BGP, I want to say that Notepad is always a friend, right? So I'm just going to keep duplicating this for all the neighbors. So I'm going to hide copy. So I'm going to paste for about I think it's about 6 or 7 of our routers. So I'm just going to keep adding neighbor 3.3. Same way for 4.4. For we don't need 5. We are not forming BGP iBGP with 5 or 6, so we're going to go straight to 7. Then we have dot .a.8, then also have it for 9.9. So I don't need to add 1.1 because we are 1.1, but I could just use it later. So I'm just going to add it here just in case we need to use it later. So I'm going to wipe this other part out because I don't need it. So I'm just going to grab this now and add it there. So I'm going to say copy. So and I'm going to paste it here. So I think we're fine. So currently, oh, I included 1. We don't really need 1, so I'm just going to say no. Now this is a big difference between your iOS XR and iOS XE. So if you use your normal router, your router will say, oh, you can't pair with your local address, so it's just going to back. But for iOS XR, it will just be there, but the peer session will not come up because technically you cannot pair with yourself as far as BGP is concerned. So I'm going to say show configuration. So if we say show configuration, so this is what we have currently. So uh, this is the global BGP process. So I'm saying for this neighbor, did I say no use? Okay, I say no use. So why? Okay, this is not really what I wanted it to do. I wanted to say no neighbor this, right? So we're going to just go back to this part. I'm going to copy it again and I'm going to say config T. I'm going to hit paste. I'm saying I don't need this neighbor actually because this is myself. Then if I say show configuration this time, so I can hit commit. I think we should be good now. So if I say show run show run router BGP, oh, seems you lost the other configurations, right? So that's not what we wanted. So I'm just going to grab this again. We got to find a way to be fast with these configurations so that we don't take much time. So I'm going to hit copy, T. I'm going to paste this in. So I'm going to leave out this. Okay, so I'm going to go back here and I'm going to hit paste. We should be good now. So if I say show run router BGP, so we're good with router 1 now. So router 1 is formally paired with router 2, 3, 4, 7, 8, and 9. So similarly, we'll go to router 2. So what we're really going to do now is let's just on this router 1, I'm going to just grab this BGP sessions and replicate in all the XR, right? So that will make it a lot faster. So I'm just going to come down on this config. I'm going to paste the BGP session. So for router 8, we are going to be running the same process, but in that case, I'm just going to add 1.1 here. So that's the only thing that we need to change. So in place of 8, we are putting 1. So I'm going to go to router 8. So router 8, I'm going to hit config T. I'm just going to blast the config. Let me copy it the second time. Copy, go to router 8. I'm just going to paste this config. So it should be good. So I'm going to say show configuration, which you should always do to validate or verify what you want to commit. Then I'm going to hit the commit command. Alright, so we're good with router 8. Which other router is running Extaro? Router 4. So in place of router 4, we're now going to put router 8. Okay, so I'm just going to grab this again because they're basically running an iBGP. So that's why it's important. We're able to do this because we know they are all pairing with their loopback addresses. So I'm going to go to router 4. I'm going to hit config T. I'm going to blast my config. So I'm going to say show configuration. See what I'm doing is okay. So I'm going to hit commit. So as it is now, we have router 1, router 8, and router 4 enabled for iBGP peering, full mesh. So the next ones are going to be router 2, router 3, router 9, and router 7. So we have more pairings there. So let's build it from router 2, then we just replicate. So from router 2, I'm going to say show run just to make sure there's no BGP process already running. Show run pipe session router BGP and not BPG. So basically you want to invent that, right? Of course not. So I'm going to say router BGP process 1. So here we don't really need to specify the address family, but it won't hurt if you do. So unicast. So I'm going to exit out of this. So I'm going to say for neighbor, I can say give the neighbor a name now. I'm going to say KI group. So it's a little bit different. So I'm going to call it peer dash group, right? So I'm going to say for this neighbor KI dash group, the remote AS is going to be 1. Same way, just like we did it in iOS XR, I'm going to say the update source is going to be loopback 0. And we could also include the address family. Say address, take it, it will take it. So those are basically the two commands we need for now for full iBGP pairing. So I'm just going to exit. Okay, so if I just go back and say do show run pipe section router BGP. So that's what we have currently as it is. So we also have it enabled for the address family. So I'm going to say for router BGP 1, I'm now going to say for neighbor, okay, I'm going to say for neighbor 170. So this is router 2, right? So it's going to be 172.20. What now? Dot 1.1. So I'm going to say inherit. So in iOS XR we use, right? So here we are going to say inherit. What do you want to inherit? A peer group. The name of the peer group. Sorry, we are going to inherit not a peer session. So we're getting this wrong here. So we're going to say neighbor. Let me use my question mark. Peer group. So instead of peer session, we are supposed to say peer group. So what's the name of the peer group? ki dot group. So I'm going to hit enter. So I'm going to grab these two now, just like we did for iOS arrow, just to make it quicker. I'm going to go to my notepad. I'm going to just paste it here. I don't want to override this. Let them be separate, just for comparison. Or should we need to use that again? So I'm just going to grab this. Let me hit enter. So I'm going to grab this and duplicate into these 6 places. 1, 2, 3, 4, 5, 6. I'm going to change the syntax. So we're currently with router 2. So we need 3.3, 3.3, 4.4, 7.7, 8.8, and 9.9. So we don't need this. I'm going to take this out. So I'm just going to grab all of these and put it there. So I'm going to go to this router. This is route 2. This is where we at. So you see the session is already coming up. That's good news. So automatically you see those sections start popping up. All right. So I'm just going to say do show run pipe section router. So no, don't mess up my parser. So section router BGP. So you see automatically deactivated in the IP-4 VRF. So I'm just going to grab this. This is what I need, right? We can just leave this, the address family. So I'm just going to grab this and go to my notepad. I'm going to just blast it here to overwrite what we got there. So for router, so the other routers are what? Let's check it out. So for router 7, so for router 7 means we don't need router 7. So this is router 7, we're just going to pay router 2. Then I think with that we are good. So I'm going to hit copy. I'm going to go to router 7. Now you don't. What I like about for iOS is even if we don't, so I could just come here to make it easier. I could just come and say, let me hit enter here. We know for XE it doesn't automatically recognize that oh you're trying to pair with yourself, but for XR, I mean for XE or for your normal iOS, it automatically could detect that. So I'm just going to put all of them. So you're going to see the errors it's going to generate once it sees you're trying to pair with its own local IP address. It's going to say no, you can't do that, right? So I'm going to grab this. I need to put it on route 7. So if I go to route 7, config T, I'm just going to paste it here. So route 7, okay, 7.7 is missing out, right? So it's repeated. So I'm going to put instead of having 2.2 here, I'm just going to put 7.7 back. Of course, you don't need to pair with 7 because we are 7. You can pair with yourself. So if I go to the next router, is going to be router 3. So we can pick router 3. T. I'm going to hit paste. So this was what I was trying to say, that whenever you're trying to pair with yourself with an IP address that is local to the device, it's going to bounce. It's going to say no, you can't do that. All right. So similarly for each other router, we also have router 8. No, router 8 is XRO. You don't want to do it on that. Router 7, we're done with router 7, we're done with router 3, we're done with router 2, 7, router 2. I think the last router there is going to be router 9. So I'm just going to go to router 9. I'm going to hit config T. Then I'm going to paste. Oh, I didn't grab it. Let's go back and we can see copy. And I'm going to paste it there. So I hope we all understand what we're trying to achieve here. So this is a way of kind of optimizing the configuration because using peer group makes it much more easier to configure and to run away from errors, right? So with the way it is now, if I say show iBGP summary, you see we have a boatload of uh, peerings, right? So currently as it stands, router 9 is paired with router 1, router 2, router 3, router 4, router 7, and router 8. Okay, so that's just the whole idea of full mesh design, right? Same way if we go to, so I'm just going to hit the uh let me send the command to all the sessions. So I'm going to say end, then I'm going to say show. Okay, so for iOS X I'm going to be show run router what BGP. So it's basically going to show me what I'm trying to say is I want to say show iBGP summary. So it should, so for router 1 currently it's pairing with router 2 all the way down to router 9 for now. Same way for router 2. So you're going to find out that we all have or full BGP session. So here tells you the uptimes. So for router 1, it has been off for 5 minutes. For 3, it has been off for 1 hour and 53 seconds. So this tells you the uptime since the neighbor has been established. Now take a look. Currently, we are not learning any prefixes from any of the neighbor. Why? That is because we are yet to originate any prefix. Remember, we talked about ways you can originate prefixes. We've not demoed it. We are going to have a separate session on different ways we can originate prefixes. But as it is now, if I say show IP BGP, so for router 5 and router 6, as you see, they are not currently enabled for BGP because what we want to have is an eBGP pairing with router 5 and router 6, same for router 10 and router 11. So let's quickly do that. So for router 6, router 6 is going to be paired with router 2. Okay, so let me bring out my pen here. So router 6 is going to be paired with router 2 of this connectivity. Same way for router 6 is going to be paired with router 4. So router 4 is going to be paired with router 10. And so you have this pairing. So we still have like how many pairings now? It's going to be 2, 4, 6 that we're going to do in each of the routers so that we can actually come to see how the connectivity is going to go through. So what I want to do now is I'm going to pause this video here. I don't want it to be too long. I don't want it to be too long. So I'm going to pause the video here, and in the next session we're going to do the configuration for the eBGP pairings, and then we'll start looking at the different pros and cons of BGP full mesh design. Thank you very much. I see you in the next video.